In this video, I will talk about the equations of motions and their derivations, and then we will solve practice problems related to the equations. Suppose that an object is traveling with a uniform acceleration a, and then it increases its velocity from an initial value of u to a final velocity of v at a particular time t. Notice that the average velocity of such object performing a uniformly accelerated motion is given as u plus v upon 2. This is the formula to find the average velocity of a body performing a uniform acceleration. Now let's say this is equation 1. Now recall that acceleration is given as the rate of change of velocity, so that is the final velocity minus the initial velocity upon time. Okay, so if I cross multiply, I'll have something of this nature, v minus u. Okay, so that if I add u to both sides, then I'll have something of this nature, a t plus u equals to v, or by taking minus u to the other side, so that v is equals to u plus at. The distance moved by that object is equal to its average velocity multiplied by time. Alright, but remember that its average velocity is given as this, so that it becomes u plus v upon 2 then multiplied by time. This is the distance of that object, but recall that v is equals to u plus at, so that s is equals to u plus at upon 2 then multiplied by t, so that we'll have something of this nature, 2u plus at upon 2 then t. Now if you expand the bracket, that will be 2u upon 2 then t plus at squared upon 2, so that s is equal to ut plus half at squared. From this equation, let's say this is equation 2. Recall from equation 2 that s is equal to u plus v upon 2 then t, but a is equals to v minus u upon t. From this formula, we can derive a formula for t where t is equals to v minus u upon a. If we substitute this formula into this expression, then s will be equal to u plus v upon 2 then v minus u upon a. Alright, so that by expansion of brackets we will arrive at something of this nature, u plus v then v minus u upon 2a. Notice that this is the difference of two squares, and then if you expand the bracket, that will be v squared minus u squared, alright, upon 2a, which is equal to s. As a result, s is equals to v squared minus u squared upon 2a. So if you cross multiply, it will yield 2as, which is equals to v squared minus u squared, so that v squared is equal to u squared plus 2as. A car is traveling at 15 meters per second, slows down uniformly to a velocity of 5 meters per second when the brakes were gradually applied. How long does it take to cover a distance of 50 meters? What is the deceleration? The initial velocity of this car is 15 meters per second. A car traveling at 15 meters, so its initial velocity is 15 meters per second. Then it slows down uniformly to a velocity of this, so that is the final velocity. The final velocity is 5 meters per second. Okay, now how long does it take? Then we need to find time t. what is the deceleration? We need to find the A. Okay, the acceleration is the opposite of deceleration. Now the useful equations of motion are s equals to u plus v upon 2, then t also v is equal to u plus at, and then v squared is equal to u squared plus 2as. Also s is equal to ut plus half at squared. We can use any of the equation provided that we have the complete parameters. So for the first equation we have s, then there is u, there is v, then t is unknown, so this is suitable for this question. We may not be able to use this equation because we don't know a yet, which is the acceleration, and we don't know t yet. There are two unknowns here. Okay, so we can make use of the one with just one unknown. All right, so 50 is equal to u, which is 15, plus v, which is 5 upon 2, then t. So 50 is equal to 20 upon 2, then t, so that 50 is equal to 10t. As a result, t is equals to 50 upon 10, which is 5 seconds. So 5 seconds is the time that it takes to cover a distance of 50 meters. Now, what is the deceleration? To find the deceleration, we can make use of the second equation. Since we have v, we have u, and then we have a now, and then we have t already, and then a is the unknown. So just one unknown. We make use of the one with one unknown. Okay. Alright, so if v is equals to u plus at, then the v in this case is 5 meter per second, the u is 15, and then the a is unknown, the time is 5 seconds. So that 5 minus 15 is equals to 5a. That is, I brought 15 to the other side of the equation, so that it yields minus 10, which is equals to 5a. If you divide both sides by 5, then acceleration a will be equal to minus 10 upon 5, which is equals to minus 2. The negative of acceleration is the deceleration, so the deceleration is 2 meter per second. All right, a body starting from rest travels for 30 seconds. Determine the final velocity attained after covering a distance of 40 meters. If a body starts from rest, it means that its initial velocity u is equal to 0. Okay. And then it travels for 30 seconds. That means the time of travel is 30 seconds. Now, determine the final velocity v attained after covering a distance of 40 meters. So the distance s is 40 meters. S equals to u plus v upon 2, then t, then v is equals to u plus at, then v squared equals to u squared plus 2as, then s equals to ut plus half at squared. Now notice that we want to find the final velocity attained. The final velocity is v, so we can use this formula as well, but we do not know a, so we need to find a. We need to use a formula, a particular formula, to first of all find a. We can also make use of this formula, but it will require that we find a. So the only formula we can use to find a is to use this. Since we have s, then there is u, there is t, but there is no a, one unknown. So s, which is s, which is 40, is equal to u, which is 0, multiplied by t, which is 30, plus half a, and then t squared, that is 30 squared, and of course that is 40 equal to 0 plus half a. 30 squared is 900. All right, so that we'll have something of this nature: half 900 a is equal to 40. If we cross multiply, that is 2 times 40, which is equal to 900a. So that 2 times 40 yields 80, which is equal to 900a. If I divide both sides by 900, 900, so that 900 cancels out in this place, so that it to be equal to 80 upon 900, which is the same thing as 8 over 90. Now, in order to find the final velocity v, we can find the final velocity v using this equation. V equals to u plus 80. So v is equals to u. The u in this case is 0, then the a in this case is 8 upon 90, and then the time in this case is just 30. So that is 8 upon 90 multiplied by 30. 30 can divide 90 in 3 places, so that we'll have 8 upon 3. So the velocity is equals to 8 over 3 meter per second.